All right, guys, let's get through a couple more of these. Let's do the leg work up front. Okay, so let's see. I know I'm going to take that 7, put it out front. Okay, 1 over. Let's see, I've got to factor that guy. Okay, dx. Okay, so let's see, we've got a 3x and an x, and that is going to have to be a plus 4 minus 1 to give me that 11x. Okay. All right, so let's see. I've got to find a way to deal with this guy. Okay, so we've got 1 over, okay, this 3x minus 1 and x plus 4. Okay, I know that's going to be some constant a over 3x minus 1 plus some constant b over the x plus 4. Okay, when I do my decomposition. Okay, so if we take this entire equation and we get rid of the denominator so that we don't have any fractions by multiplying by 3x minus 1 times x plus 4. Let's see, this guy will cancel with that guy, so you're just left with 1. Okay, so let's see, this 3x minus 1 will cancel with this 3x minus 1, so I'll be left with an x plus 4 times the a. Okay, so a times x plus 4 plus, let's see, this x plus 4 will cancel with that x plus 4, so I'll be left with 3x minus 1 times the b. Okay, so b and 3x minus 1. Okay, let's see what happens here. Okay, so let's see. If I want to get rid of this guy right here, I'd have to let x be negative 4. Okay, so let's see what happens there. So I'd have the 1 on the left-hand side. This would be a times 0. Okay, and this guy, let's see, that would be a negative 12, that'd be a negative 13. Okay, so this just drops out, and I divide both sides by negative 13, so my b ends up being negative 1/13, like that. Okay. All right, so let's see. All right, I got rid of this guy, so I want to get rid of this guy. So let's see what happens here. What would I have to do? I'd have to let x be 1/3. Okay, because that would be 3 times 1/3 is 1 minus, yeah, absolutely. So I get the 1 on the left. Okay, let's see. I've got a, and then let's see, 1/3 plus 4 is 4 and 1/3. Okay, so 4 and 1/3 plus b times, let's see, that would make that 0. Okay, so let's see, I get 1 equals, let's see, that would be 13 thirds, okay, times a. So if I divide both sides by 13 thirds, I'm getting a is equal to divide positive 3/13. Okay. All right, so we've got that stuff taken care of. So let's see what we can do here. Okay, so I have this 7 times this guy up here, 1 over this 3x minus 1 times x plus 4 dx. And that has to be equal to 7 times, let's see, something over 3x minus 1 dx plus 7 times something over the, I'm sorry, I want to put 1 there. Okay, something over the x plus 4 dx. All right, so let's see. I put the a with the 3x minus 1. So my a has to go here, 3/13. Okay, I put the b with x plus 4. So my b has to go here, negative 1/13. Okay. All right, so let's see what we got going on here. Okay. Let's see, move that guy up. All right, and I'm dealing with this stuff over here. Okay, so if I bring this numerator out as a constant multiplier, okay, it looks like I'm going to get 21/13 times the integral of 1 over 3x minus 1 dx plus, well, actually it's going to end up being minus. Okay, so let's make that a minus. And if I bring this guy out front as a constant multiplier, I'm going to get a negative 7/13 times the integral of 1 over x plus 4 dx. Okay, so we should be in good shape here. So let's see what happens. Okay, I've got to do both of these. Looks like using u substitution. Okay, so right here, if I let u equal 3x minus 1, then my du ends up being 3 dx. Okay, so I would get 1/3 du equals dx. Okay, so I'm just going to do this guy first, and then I'll come back and do this guy. Okay, so I've got the 21/13. Okay, this would be 1 over u times 1/3 du. Okay, so let's see. I bring this 1/3 out front, so the 3 will cancel with the 3 here, so I'd be left with 7/13. Then I integrate 1 over u, so I get the natural log of u. Okay, and so I go back and put my 3x minus 1 in there. Okay, so I get 7/13 times the natural log of 3x minus 1. Okay, let's see. All right, so if I do the same thing here, I'm going to let u equal x plus 4, so my du is dx. Okay, so let's see, we've got this minus 7/13 times the integral. That would be 1 over u du. Okay, so I get this minus 7/13. When I integrate 1 over u, I get the natural log of u. Okay, oh, this is going to be a minus sign here. I don't know why I have a plus there. Okay, so minus 7/13 times the natural log of my u, which is x plus 4. Okay, then plus my constant of integration. Okay, so let's see. What can we do here? All right, notice that you have a common factor of 7/13. So if I pull that out, I'm left with the natural log of 3x minus 1 minus the natural log of x plus 4. Okay, plus my constant of integration. Okay, and then I can use the quotient rule here because it's minus. Okay, I like that. Okay, so it would be the natural log of this guy over that guy. Okay, so 7/13 times the natural log of 3x minus 1 all over x plus 4 plus c. Okay, so I definitely have one form of the answer. And I'm wondering if I can come up with another form that would maybe be a little bit cleaner, maybe not. The only thing I can think to do is to bring this 7/13 back, okay, as an exponent. Okay, so let's see, what does that look like? So it looks like I would have the natural log of, it would be the 13th root, okay, of this whole thing to the 7th power, 3x minus 1 over x plus 4 to the 7th power plus c. And notice that the exponent in the radicand is smaller than the index number, so that's in simplest radical form. Okay, certainly there's no way I'm going to rationalize this. I mean, no way. So I would say, yeah, you know, either one of these two guys is good. I don't see any reason to mess around with it anymore. I think they're all in good shape. Okay. All right, so we got that guy out of the way. Okay. And let's see what happens here with this guy. Okay, so let's see. All right, I'm going to pull that -9 out front. Okay, and then let's see. I would have 1 over, let's see, dx. I've got to factor this guy. I'm thinking it's 2x and 2x, like this. And obviously both of them have to be minus. So let's see, will it work with a 3 and a 5? So if I put a 3 here and a 5 there, let's see, that would give us a negative 6x, and a negative 10x, which gives us a negative 16x. Okay, so we're good there. Okay, so let's see. I've got this guy, and I know I'm going to split that up using partial fraction decomposition. Okay, and let's see. Okay, so I'm going to just deal with this guy right here. Okay, so I know I have that 1 over 2x minus 3 times 2x minus 5. That's going to be equal to some constant a over 2x minus 3 plus some constant b over 2x minus 5. Okay, so once again, we want to get rid of these fractions. Okay, so we multiply through by 2x minus 3 times 2x minus 5. Okay, so that'll cancel with all this here, so we're just left with 1. Let's see, this 2x minus 3 will cancel with this 2x minus 3, so I get a times 2x minus 5. Okay, and let's see, this 2x minus 5 will cancel with that 2x minus 5, so I'll get b times 2x minus 3. Okay, so we got to figure out what we can use for a and b. So let's see. If I let x be 5 halves, then this 2x minus 5 will be 0. So if x is 5 halves, I get 1 equals, let's see, a times, let's see, 2 times 5 has to be 5 minus 5, that'd be 0, right? Good. Plus b times, let's see, 5 halves, so that would be 5 halves times 2 is 5, 5 minus 3 is 2. It's like that. Okay, so this cancels off, and so I get 1 equals 2 times b and divide by 2, so I just get b equals 1/2. Okay. All right, so let's see. Okay, now I want to get rid of this guy right here, so I would have to let x be 3 halves. Okay, let's see what happens there. Okay, so I've got my 1. Okay, if x is 3 halves, 2 times 3 halves is 3. 3 minus 5 is negative 2, so I would get a times negative 2. Okay, plus, well, 2 times 3 halves is 3. 3 minus 3 is 0, so I'd get b times 0. Okay, so this just drops out. Solve for a, divide by negative 2, so I get a equals negative 1/2. Okay, all right, so let's see what we got going on here. All right, so I've got my negative 9 times the integral of 1 over 2x minus 3 times 2x minus 5 dx. That equals negative 9 times the integral of something over 2x minus 3 dx. Plus negative 9, so it would be minus 9 times the integral of something over 2x minus 5 dx. And let's see, what did I put with the 2x minus 3? I put the a with the 2x minus 3, so that means my negative 1/2 goes here. Okay, 2x minus 5, I put the b with the 2x minus 5, so that means my b goes right here, 1/2. Okay, so we should be in good shape here. Okay, so let's see. Okay, well, I am going to pull these numerators out as constant multipliers. Okay, so when I pull that guy out front, multiply by the negative 9, I get a positive 9. Okay, so I'd have 9 halves times the integral of 1 over 2x minus 3 dx. Okay, that works. I pull this guy out front, okay, multiply it, so obviously it's not going to get rid of that minus sign, so it's going to be minus 9 halves times the integral of 1 over 2x minus 5. dx. Okay, let's see, got it right? Okay, we're in good shape then. Let's see what happens. Okay, so again, I'll just take them one at a time. So let's see, my u is 2x minus 3. So my du ends up being 2 dx. So I get 1/2 du equals dx. Okay, so I've got the 9 halves out front. Okay, this becomes 1 over u. And my dx is 1/2 du. Okay, so the 1/2 becomes a constant multiplier, goes out front, so I have 9 halves times 1/2, so I get 9/4. I integrate 1 over u, so I get the natural log of u, and then I go back and substitute. So I've got 9/4 times the natural log of u is 2x minus 3. Okay, so let's get this other guy. Okay, let's see, so my u ends up being 2x minus 5. So my du is 2 dx. So I get 1/2 du equals dx. Okay, so I get this minus 9 halves times the integral of, this would be 1 over u. 1 over u times my dx is 1/2 du. 1/2 du. Okay, so again, constant multiplier of 1/2 comes out front, so that's minus 9/4. Okay, and then I integrate 1 over u, so I get the natural log of u, and I can put my constant of integration in there now. So we have minus 9/4. U right here is 2x minus 5, so I get the natural log of 2x minus 5. Okay, plus the c. Okay, and let's see what we can do. Okay, you do have a common factor of 9/4, so I could pull that guy out if I wanted to. 9/4 times the quantity of the natural log of 2x minus 3 minus the natural log of 2x minus 5 plus c. And again, I got minus here, so I can use the quotient rule to be the natural log of this binomial over that binomial. Okay, so 9/4 times the natural log of 2x minus 3 over 2x minus 5 plus c. And I would say that this definitely is a form of the answer that we could use. I like that. Okay. You want to play around with it a little bit, see what we could do with it. So let's see. I could bring this 9/4, bring it back. Okay, so that would be the natural log of the 4th root of 2x minus 3 over 2x minus 5 to the 9th power plus c. Okay, I suppose that's another method. Okay, maybe we could leave it that way. I don't like this as much because it's not in simplest radical form, because notice that the exponent in the radicand is greater than the index number. So if I'm going to go this route, certainly I'm thinking I got to go simplest radical form. So if I do that, okay, let's see what we would get. Natural log of. Okay, so that'd be the 4th root of 2x minus 3 to the 9th. Okay, so that would be 2x minus 3 squared times the 4th root of 2x minus 3. Okay, and let's see. Down below, I'm going to get something real similar. That would be the 4th root of 2x minus 5 to the 9th. So that would be 2x minus 5 squared times the 4th root of 2x minus 5 plus c. And notice how it's starting to get a little muddy here. I don't know if this is taking me in a direction I want to go. I'll finish it and then we'll just take a look at it. So let's see. That would be the natural log of. Well, I could write these guys out front. I could write that as 2x minus 3 over 2x minus 5 squared and then these are both, they both have the same root or index number. Okay, so times the fourth root of 2x minus 3 over 2x minus 5. Okay, like that, and then plus my constant of integration. Okay, so if you take a look here, you know, going down this road, I mean, obviously these are all forms of the same answer, okay? And, you know, depends on who's the front of the classroom. I mean, but I just think once we move this guy back as an exponent and start working in root form, it starts getting pretty ugly here. So I certainly would not gravitate towards these guys down here. One of these two guys, and even looking at these two guys, I'm thinking this guy looks a lot cleaner than this guy. So I would probably gravitate towards this answer right here, okay? All right, that'll wrap it up for today, and we'll get into sort of a different situation tomorrow, but same types of problems. You guys make sure you get in touch if you need anything, okay, and stay safe. I know I say that every day, and I miss you guys a whole bunch.